Today we are going to look at one methodology, one technique for analyzing relationships, and that is correlation and regression. The first thing you need to know about these two is their simple definitions. Correlation deals with association. Regression deals with causality. Correlation deals with association. Normally, this is a compulsory question, so I'm trying my best to make you fully get it. Correlation deals with association. Regression deals with causality. Okay. So regression looks at cause and effects, whereas correlation looks at just relationship. So for example, I can tell you that there is a relationship between price and then the quantity demanded. I can tell you that. I can tell you that there is a relationship between price and quantity demanded, but that does not mean that price is causing the quantity demanded to change. It could be that the quantity demanded is rather causing the price to change. So correlation looks at the relationship, regression looks at the causality. Now, take for example, consumption and income. You and I will agree that consumption and income has some relationship. Now, it is possible that consumption causes income to go up, because if you are consuming more goods, you'll be tempted to increase your income level. Maybe you do extra work so that you can have more disposable income. Because you are consuming too much, you are buying iPhone, you are buying this, you are buying that. So your consumption behavior can cause your income behavior to change. But it's also possible that as your income is also increasing, you'll be tempted to consume more. So the thing is, consumption and income have got a relationship. That is just correlation. But consumption and income also have got causality or causal relationship. So causality looks at causal relation. Now when you're looking at which is causing and which is not causing. So I want you to know that correlation does not mean one is causing the other. It simply shows that there is a relationship. For example, you will agree with me that a relationship can even be positive or it can be negative. For example, what do you think is the relationship between price and quantity demanded? Is it positive or is negative? You can type or can raise your hand. The relationship between price and quantity demanded, is it positive or is negative? Positive or negative? Adam says negative. Sakite says negative. Daniel says positive. Elena, Mark, they are all saying negative. So the relationship between price and quantity demanded is negative. Why? The reason why we say it's negative is because the relationship is in such a way that when one is going up, the other is coming down. Okay, it is like what you see on your screen. When one is going up, the other is coming down. So when price rises, quantity demanded falls. When quantity demanded rises, price falls. That is what we mean by a negative relationship. But it can be a positive relationship as well. For example, consumption and income. If your income is rising, consumption is rising. Now watch it. I didn't say income rising is causing the consumption to rise. I'm only saying that they all move in the same direction. That means the relationship is positive. So watch something. The relationship is positive and it can also be negative. And then we have a situation where the relationship is strong or weak. The relationship can be strong or weak. Take, for example, what I'm about to show you here. Okay. If you have correlation, is usually between -1 and then +1. In the middle is 0. So on this line here, you have the line going this way and going that way. The closer you are toward 0, the closer you are toward this 0, the relationship, is it getting weaker or is getting stronger? Suppose you're moving from +1 coming towards 0, or you're moving from -1 coming towards 0. What is happening to the relationship? Is it getting weaker or is it getting stronger? It's getting weaker. It's getting weaker. And the reason why it's getting weaker is because the strength of the correlation is getting to 0. So there is something you got to know. And you got to know that pretty well and pretty fast. So what you want to notice this. You can have a negative correlation that is strong. And you can also have a positive correlation that is strong. And you can have a negative correlation that is weak. And you can have a positive correlation that is weak. The negatives and the positive doesn't matter. It doesn't determine the strength of the correlation. So if you're writing things down, write this down. The strength of the correlation is determined by the numerical value and not the sign. The strength of the correlation is defined by the numerical value and not the sign. So let me ask you this. I'm going to write two numbers. One is -0.89. The other is 0.76. And you got these two numbers. Now, the question is, are these two numbers, which one is strong and which one is weak? The top one or the down one? Which one is strong and which one is weak? The top or the down? Top or down? Which is strong? Which is strong? Which is strong? Is a top one. Very good. Okay, is a top one. Why? Because the top one is the one that has a higher absolute value. Okay, so when the absolute value is higher, that is when we say the correlation is strong. So take note, a high correlation, it can be high negative and it can be low positive. Okay, so the fact that the thing is negative doesn't make it small. It doesn't make it low. It is still high, even if it's negative. The sign doesn't matter when you're determining the strength of the correlation. So that's it. Now, what I just showed here is known as the Pearson's product moment correlation. Okay. Pearson's product moment correlation coefficient. Pearson. So this is a statistic. Okay. This is a statistic, and this statistic is between -1 and then +1. And that is the statistic for measuring correlation. Okay. -1 and then +1. All right. Now, how do you go ahead from, now let me ask some of you, if I were to ask you that, what is a relationship between you and your spouse? What's the relationship between you and your partner? If you are to give it in monetary terms, percentage terms, some of you should write the percentage for me. The current relationship between you and your spouse, what is a percentage strength of the relationship? What value will you give percentage-wise? Write some of them down. Let me see. If there is no, if you don't have any relationship, just write 0. Because 0 means that there is no relationship. So those of you who are not 0, and of course, nobody should say that the relationship between you and your spouse is 100%. Because once you say it's 100%, what you are saying is that the two of you are perfectly correlated. It means both of you are males and both of you are female. Okay. So there's nothing called perfect correlation in real life. Okay. But you can ascribe some percentage value to it. Okay, so what is a relationship? Somebody should tell me his. Let me see. Somebody says 90%. Somebody says 0. Please, those of you saying 0, those of you who are also 0 should monitor and watch them. Because when somebody says 0, it means that there is a veritable chance of that person increasing the 0 to 10%, 20%, 50, and 90. So the essence of this exercise is for you to mention your 0, so that somebody will see your 0, and then he too will mention his 0. Then the 0 and the 0 can change in numerical quantities. Okay. So please, everybody, let me know. I see 45%. I see 80%. Somebody is writing 99%. I see if the other person agrees with him. Okay. When you write 99%, it doesn't mean anything. It simply means that you are showing off, because you are making it look like there is no problem at all. Everything is smoothly. You're almost even perfect. There's no wahala. Okay. So, zeros. You see, I'm seeing a lot of 0%. For example, Doris mentioned 0%, and then what's his name? Chachu mentioned 0%. So you can see the connectivity. Somebody is mentioning negative 81%. That's possible. Okay, negative 81% means that the two of them are about to kill themselves, okay, in any moment from this weekend. So the strength, you see, just attaching the numbers to the correlation can tell you something. It can tell you the strength of the relationship. The strength matter, because the number will tell you the strength. Okay, so with that in mind, we can go ahead and establish that correlation exists when two variables are highly related. Okay. When two variables are related to each other, then we have a correlation. Let's go beyond correlation. Beyond correlation, there is something known as causality or regression. And to do that, but before then, let me just ask you on the screen, tell me the relationships you see here. You're going to tell me which one is exhibiting positive or negative relationship and which one is exhibiting what else. So please look at the relationship. The top left here. What is a relationship? Is it positive or negative? You can raise your hand or type the answer. Is it positive or negative? The top left. Say what is in your head, not what somebody has written. It's positive. Okay, the relationship between X and Y are positively related. Now, what about the one on the bottom left? Bottom left, is the relationship positive or negative? Po or ne? Okay, the one on the left, is it po or ne? Sakite, raise your hand, and then, yes, Sakite, tell me, is it po or ne?
Negative, sir.
It's negative. Okay. So the relationship between X and Y is negative. Now, who can tell me the relation between this one? The one on the top right here. Is the relationship positive or negative? Top right. That one is not simple. That one is not simple. Top right. Who can tell me? The relationship. What is that? It is not ponnet. Doris, the relationship is not ponnet. It's not ponnet. What is a relationship, Van Dyke?
Sir, it is positive from the beginning, and then midway, then it changes to negative.
Okay, that's wrong. What is a relationship in the top right one here? What is a relationship there? It's not positive. It's not positive. It's not positive. Yes, Sakite. What is a relationship?
No linear relationship.
So what is a relationship?
Like there's no relationship.
There is. There is. There is a relationship. The relationship is quadratic. It's quadratic. Do you realize the thing is looking like quadratic graph? Okay. Like, you remember the good old days of ogive? That's how I used to call it, ogive. Okay, ogive. That's it. Quadratic relationship. Take note. When you see something like this in an exam, you don't panic. Okay, so that's O guy. Now look at the bottom right. The bottom right. I want you to ask, because if I ask, it shall be war. The relationship is more or less, it's curvilinear, okay? Logit model, probit model, tobit model, okay? More of censored models. So that's a very strange kind of relationship. So the point of this exercise is just to let you know that there are several complex relationships that can be obtained from all of this. Okay, so keep that in mind. And now let's go to regression. So what is regression? What is a relation? What's the difference between correlation and regression? I've already told you. The difference is that correlation deals with association, regression deals with causality. Now, in a regression, there are two kinds of variables that we analyze, particularly in a simple regression. There are two kinds of variables that we tend to analyze. So follow me here. The first variable is the y variable, okay, the y variable. And this y variable depends on certain things, starting with beta naught, and then beta 1 x. Then there's something called epsilon or mu. I'm going to just explain the simple regression before I go to the multiple regression. The y variable is known as dependent variable, but it has two other names. Who can tell me the two other names for the dependent variable? Please pay attention a lot here. The y variable is known as dependent variable. It has two other names. What are they? What are the two other names for the dependent variable? Okay, the first one is known as response variable. The dependent variable is also known as the response variable. It is also known as the explained. The explained. Sometimes it's also known as the outcome variable. The outcome variable. So that is a dependent, okay? Now, the other variable here is known as the independent variable. The independent variable, IV, has other names. Who can tell me another name for the independent variable? Another name for the independent variable. Another name. The independent variable is also called another variable. What is it? Emmanuel. Another name for the independent.
Explanatory, sir.
Explanatory. Give me another one. Give me another one apart from explanatory. Adam.
Predictor.
Predictor. Very good. Give me another one. Give me another one. Get to know these names. Those of you who don't know, get to know the names. Okay. Another name is the regressor. Regressor. Okay, so take note. The independent variable is known as predictor variable. It's also known as the regressor. The regressor. And the dependent is usually called regressand. So the independent is a regressor, and the dependent is known as regressand. Explanatory is also another name, explanatory variables. Explanatory variable. So you got to know the other name. Now, I'm going to tell you the relationship between the dependent and independent variable. The dependent variable, the behavior in the dependent variable is caused by the independent variable. The behavior of the independent variable causes the behavior of the dependent variable. So the independent variable is the causal factor. Is a causal factor. It's a cause. It is a cause. Whereas the dependent variable is a recipient of that cause. Is a recipient of that cause. So take note. The one on the right-hand side is the causal factor, and the one on the left-hand side is the, the recipient, the response factor. So it means that the dependent variable is affected, is influenced, is dependent on the independent variable. Okay. Now let's take a typical example. Okay, let's take a typical example of real life situation. Of course, in the real life situation I'm going to make it multiple so that you get more independent variables. Now, before I do that, let me just go back and then watch the other term. Let's look at the other terms before we go here. There are other things that are there. One of them is the beta naught. The beta naught is one of the beta parameters. It has no real economic interpretation, to be honest with you. It is the y-intercept, mathematically speaking. It is the y-intercept, is the constant. It has no meaningful, economic interpretation, except that it is only useful during prediction. We'll come back to that. Okay. It is only useful during prediction. What do I mean by that? Well, suppose we know the value of the x, the independent variable, and we want to predict the dependent variable. Some of the content in the beta naught might help. So that is when the beta naught becomes useful. That leaves us with the last element in this regression. What is that last element? That last element is known as U here. Okay. Sometimes it's called epsilon. Sometimes you see this epsilon. Okay. Sometimes you see mu. Okay. Mu. Okay. Sometimes you see U, or even sometimes you see E. Either way, this is called the error term. But there are 6 other names of the error term you got to know. If you check my couple of last year's question, I asked you, what are some of the 5 other names? There are 6 other names of the error term you got to know. Who can give me another name of the error term? Who can give me another name of the error term? This one, if you know, you know. Okay. Normally, if it was in class and you're seated by the right person will help you. Okay. But sometimes if you're in your house and you're alone, you don't get that much help. Okay. So what is another name for the error term? Stop Googling. Stop Googling. It won't help you. The worst form of learning is when you see the answer before you answer. What is another name of the error term? The error term. The error term. The error term. What is another name of the error term? Okay, let me see. Oh, that's beautiful. That's beautiful. Another name of the error term. Okay, I'm going to give it to you as an assignment. Get all the 6 other names of the error term. Okay, because you should have watched this before coming here. Okay, now your answer is wrong. Significance level is not another name of the error term. The error term, this one, the error term. What is another name of it? Go find out all the 6 different names of the error term. Okay, now let's move on. Now, so with this in mind, let's take a practical example. Okay, let's take a very practical example of this. I'm going to give you a model. What I'm about to write is a model. Okay. The model is given by marriage, or you can even call it relationship. Okay. But we want to get to the established one, marriage. And marriage is dependent on several factors. The first one is beta 1 and the factor going with it. I'll come and explain the beta ones and the rest. Which factors can affect marriage positively or negatively? Can you mention some? I have so many in my head. Which factor? I know the first one that will come. Okay. The first one, let's take love. Love. So that's beta 1. Plus somebody just mentioned money. So I'll write beta 2, money. Okay. Who can give me another factor? Beta 3. What is beta 3? And there are some of the things I will determine whether you are right or wrong. Some of the things you are mentioning, I don't buy it. Okay. I don't buy it. So I won't talk about communication, unfaithfulness, all of those things. They are eating from love. So religion, take all of these things out. Okay. Let's look at one factor, age. Age. Now, not all of these factors must be positive or negative. Some can even be neutral. Okay. But it must not be eating into another. How can you say concern? How can you say concern? Concern. What is concern? What is hatred? Okay. You people are together, now you're saying it's hatred. Okay. In-laws. Okay, somebody mentioned in-laws. In-laws can affect the relationship. Okay. And what else? What else? Somebody mentioned side chicks. Okay. So he's talking about, let's say, other girlfriends and boyfriends, those sort of things, isn't it? Okay, so how do you put it? What is one keyword you can use for that? Okay. Oh, yeah. Some of you are mentioning some smart ones, eh? Okay. Children. Okay, so let me just come to kids first. So kids can strengthen or not strengthen the relationship. Then let's go to beta 6. Somebody wrote it in capital letters, telling me that I should write it quickly. 6. Okay, so that is also another one. What else? I like the word the other person has written. I think that's the word I was looking for. Beta 7, concubines. Concubines. Okay, and several other things that I can't tell now. So let's put all of them together and call it you. That you are you. So what is the you? What is the error term? The error term is also known as the unobserved heterogeneity. Okay. What is the error term? It's also called disturbance term. What is that error term? The error term captures all other factors that can affect the dependent variable, but cannot be included or were not captured. All other factors that can also affect the dependent variable. In our example here, the dependent variable here is marriage. Okay. And all other factors that can affect the marriage, which were not captured here, are called the error term. The UI, the error term, the error. You see, it is called the disturbance because it disturbs the relationship. All those factors that disturb the relationship, positively or negatively. All right. Now, what is the beta 1? You are seeing some betas being mentioned there. What is beta 1? What is the beta 2? What is the beta 3? What is the beta 4? What is the beta 5? What is the beta 6? What is the beta 7? The betas, and you want to write this down, the beta parameters tell you, the beta parameters tell you by how much each independent variable, by how much each independent variable influences the dependent variable. It tells you by how much the independent variable influences the dependent variable. Okay, let me make it practical so that it can make sense to you. So here we are. Everybody is claiming to influence marriage here. Love says, I can influence the marriage. Money says, I can also influence the marriage. Age says, I can influence the marriage. In-laws, they claim to influence the marriage. Sex says, I can influence the marriage. Concubine says, I can disrupt the marriage. Kids say, I can disrupt the marriage. So there are several other factors which couldn't even be captured, which are all inside the error term. Now, the question now is, everybody claims to be influencing the marriage, but the question is, by how much? By how much? So the beta parameter, okay, take note, these beta parameters, they tell you by how much each independent variable influences the dependent variable. So what do they measure? They measure the marginal effect. That is a very econometric term that I'm going to use here. They tell you the marginal effect of each independent variable on the dependent variable. They are numbers. But right now, because what you are seeing here is a model, you don't know the actual numerical values yet. When you get to estimate this model, the numerical values of the betas become something called coefficients or estimates. Okay, the coefficients. The coefficients or the estimates are the numerical values of the beta parameters that we are looking for. So suppose that love is 5, and money is 10. What it means is that money influences marriage by more compared with love. Okay, but of course, it depends on the unit of measurement of money, because maybe a 1 unit of love is more powerful than a 1 unit of money. Okay, so, but the key point is that the number in front of the independent variable tells you by how much that particular regressor predicts the dependent variable. Okay, that's it. If you don't understand, raise your hand. Okay, so that is what you want to know. So that is the beta parameter. Their job is to tell you by how much. Okay. Whereas the error, the error term tells you other factors that could explain the marriage, but have not been captured, so they become the unexplained factors. Whereas each one of these independent variables becomes explanatory factor. Explanatory factor. Let's take a practical one, and I'm going to ask you to mention some things for me. So let me go back to the drawing board, and then you tell me some few things here. Okay, follow me here. Follow me. So what I showed you was a multiple regression. Okay. Now I want you to look on the screen now. I'm showing you another example of a multiple regression, but this time it is wage. Your wage, you will agree with me, that is influenced by education, experience, position, ability, and of course, other factors. Unfortunately, those other factors can all not be written, so they are all captured in the UI, the error term. Please, can one of you tell me which other factors can affect your wage but haven't been captured here? Okay. Of course, the factor you're about to mention must be relevant. And for now, I'm the only one who will determine which one is relevant, okay, so that we don't have anything being mentioned. Okay. So who can tell me a factor that can affect wage but have not been captured here? Which other factor can affect wage but have not been captured here? Which other factor? Okay, so someone says education, but education has already been written. Job tax, no. Leadership ability, no. Working, I will buy Emilia, your answer. Overtime, that's the first one. Overtime. Now, Kwale, what is office romance? It's not needed here. Please take office romance away. Okay, rent, no. Employer, no. Location, Abigail, I'll buy your location. Okay. Nana Benya, allowances is nothing because it's part of the wage. So you got to be clear what brought about allowances. Okay. Location is good. Promotion is out. It all goes into your position. Bills is not important. It's not even quantifiable. Rex, Evelyn, I'll buy your Rex. Okay. I'll buy your Rex. Tenure of work, no. Opportunities, no. Performance, no. Inflation, yes, but I don't want other macroeconomic factors to be mentioned. So inflation, GDP, exchange rate, interest rate, all of them, let's put it into one, call it macroeconomic factors. Success is meaningless, Abigail. Okay. Mary, performance is not, award schemes is not, appraisal is not, okay. All of these will come and feed themselves into something. The type of work is part of the risk, okay. It's part of the weight. So that's it. Okay? All of those factors that I mentioned, yes, those are the fine. Let's take another example. Let's take another example. I hope that you are mentioning some. Okay, don't sit down, just mention your own. Let's go to another. Blood pressure is affected by your age. We all know that. Okay, blood pressure is affected by your age. We also know that blood pressure is affected by your weight. Okay, it's also affected by your stress and your pulse. But of course, there are other factors. There are other factors that can affect blood pressure, and all of them are contained inside the aerotem. Can you tell me other factors, relevant or relevant factors that can affect blood pressure but have not been captured yet? Don't mention broken heart. Nobody should mention broken heart. Okay, so first one, genetic, correct. Genetic and family history are the same. Diet, that is number 2, correct. Genetic, diet, races out. Exercise, very good, number 3. Exercise, underlying health conditions. Let's put it together and call it all other diseases. That is good. Pregnancy, great. Okay. Pregnancy, great. Some of you are mentioning the thing by copying your answers somewhere. When you are doing that, is up to you. You don't, lifestyle is not correct. It's too broad. Stress. Who is mentioning stress when stress has already been mentioned? Right. How can you mention stress when you can see clearly on this screen here that stress is mentioned? And you're also mentioning your own stress. Or you have another stress that is not stress. Dietary, we've already mentioned diet. Anger, no. Sedentary lifestyle, no. You think that anger leads to blood pressure is a lie. Okay, it's a lie. Substance abuse, which substance abuse? Okay. I said don't mention broken heart. And because Hannah Kotoshe has gotten broken heart, she's mentioning broken heart for people to know that she has broken heart. When I mentioned earlier that nobody should mention broken heart. All right. So all of these are the factors that can cause blood pressure, but were not incorporated. Let's go to another example. I just wanted to know how regression really works. Another example. The next example is quantity demanded. The quantity demanded of a commodity is affected by the price of the commodity. Listen carefully so that I don't go and mention them again. It is also affected by the income, whether the good is a normal good, an inferior good, or a gifting good. The income of the person determines the quantity demanded. The next is advertisement. Advertisement can affect the quantity demanded. Usually, the more adverts you do, the more the quantity that will be demanded. And also complement or substitute. Sometimes it is called the price of other goods or related goods or availability of other goods. Listen well before you go and mention them. Okay, now, there are other factors that can affect blood pressure which are contained in the error term. Who can tell me some of those factors? Relevant, it has to be relevant. Taxes is one good one. Nobody should mention taste and preferences. Nobody should mention taste and preferences. So I'll take the first one, which is taxes. Okay, taxes. That's good. What else? Apart from taxes. I don't buy quality. I don't buy consumer behavior. I don't buy market size. I'll buy location. I'll buy location. Okay. What else? Okay. Evelyn, stop copying things from me. Okay. What else? What else? Apart from location, you have population. You know the population can affect that. Okay. The type of good. I mentioned the type of good. I mentioned seasonality. Thank you, Rhoda. That's a smart answer. Seasonality. I hope you guys are not copying things from anywhere and be mentioned, especially Abigail. Okay. Seasonality. Seasonality. Okay. So seasonality. Some goods will be bought a lot during Christmas season. So seasonality can affect. And then expected price. Price expectation. Seasonality. Seasonality. How can you say corruption? Stop that. Stop that. Adam, some of your answers you are giving today are very, very wrong answers. Very wrong and very controversial answers. Okay. Stop mentioning them. All right. So religion, depending on the type of commodity. Okay, nobody should mention macroeconomic factor. All right. So these are the factors that can affect the quantity demanded of a commodity. Okay. Whilst we are mentioning these, and I'm telling you this thing, yours is to be writing them down, because these same things are what you need. Okay. So those that are wrong, that I'm saying they are wrong, you don't have to give them back to me. So take note, keep writing, even though you are listening. All right. Now, I want you to look on the board and look at the two information that I'm about to show you. The first one is the first bullet here. The second one is the last bullet here. So, ladies and gentlemen, watch the first bullet and then watch the last bullet carefully. One of them, the first one, is called a regression model. The second one is called an estimated regression equation. The first one is called a specified regression model. If you check last year, you see that I asked you a question in this on the exam. Okay, Deborah, you have a question. Deborah. Deborah, was your hand up? If it is up, raise it again. All right. So you have the estimated regression equation at the bottom here, and then you have the specified regression model at the top. There are two main differences between these two. Who can tell me both differences? There are two main differences between the estimated regression equation, the one down here, and then the specified regression model. Even though they all seem to have the same dependent variable, there is some differences. Two main obvious differences. Who can tell me? All two, not one, but all two. All two. Okay, not one difference, but all two differences. Because one difference is too obvious. Okay. If you are not copying from anything, tell me. Let me go to Oha Evans.
Okay, Doug, thank you. The first is that the coefficient of the first one, the one that has the I, has
mentioned the name.
The regression the one with I, the which I.
The regression model is at the top of it.
Okay, so the regression model.
Mm-hmm.
Yes, so the coefficients are not stated, like they are not given in their numerical values.
Mm-hmm.
And then
compare it with the other one before you go to the and then.
Okay, but whereas the wage without the one without the regression model has its numerical value stated, that their coefficients are stated clearly.
Okay.
And also the one with the regression model has the error type, that is the U. Whereas the second one do not have the error type attached to it.
Very good, very good. That error type is called the error term. The error term. So that is it. So guys, know the two differences. I've brought it multiple times in an exam. So understand the two differences. The first difference is that the specified model at the top has an error term, but then the estimated equation at the bottom has no error term. Then the estimated equation has numerical coefficients for the betas, but then the specified model has Greek letters for the beta parameters. So you got to know the difference between the two. Kwame, Michael, you have a question? I don't know whether Michael, you've got a question or not. But if you can unmute yourself and then ask your question. Unmute yourself, Michael, and ask your question.
Okay, so please, I have a question. Can you also say that the wage coefficient has the numbers which is attached to it represent the importance of the various, is it variables or the various components under it? So let's say education, experience, position. So we can say that, let's say, experience has the highest importance, experience affects wage more than, can you also say that the numbers represent how important it is? Okay.
No, I mentioned earlier that the numbers could be different in terms of what they are doing. For example, if education here is dealing with years, then 0.85 will not even be 1 year. If experience is dealing with, months and not years, then 2.4 wouldn't be much. If 0.25 is so you got to know what they are representing, what the numbers are representing, what they are measured in, and whether those measured in items are being used in analysis. 0.05 ability might be smaller than 2.5 or 2.4, but that 0.05 ability in the world of ability might mean more. Get a point? It might mean more in terms of ability. That is a lot. So they don't really mean that one is better than that. It just shows that partial relationship between one particular variable and another. Okay. So we've been able to understand this. Now let's go to the assumptions of regression. What do we mean by assumptions? When we say assumptions, well, in simple terms, assumptions are certain things that must be in place for certain things to work. Basically, to a 4-year-old child, assumptions are certain things that must be there for certain things to work. And today we are looking at regression. The regression is a technique like ANOVA, MANOVA, structural equations modeling, and several things. Now, before the regression technique is called ordinary least squares, OLS. Ordinary least squares. Now, for regression to work, one of the assumptions says that there must be linearity. What does that mean? It means that the relationship between X and Y must be linear. Now, what do we mean by a relationship that is linear? A relationship that is linear is something like this. It deals with a line, but it can also be that going upward. It can be that going vertical. It can be this going horizontal, as long as it's linear. That is not the same as a relationship that is zigzag like this. Such a relationship is not linear. Or a relationship that is quadratic, okay, or nonlinear, like that. So one of the assumptions is that the relationship must be linear. When one rises, one must fall consistently. Or when one is falling, the other must be falling consistently. Or when one is rising, the other must be rising consistently. So that is what we mean by linearity. The second assumption, before regression can work, there must be normality of the residuals. Another name of the errors is called residuals. What is the residuals? The residuals are the same as the error term. Okay. The residuals is the same as the error term. One of the assumptions is that the error term must be normally distributed. That is what to be right. The error term, you see this time I'm using epsilon for the error term. I was using U before, same thing. Okay. The error term must be normally distributed. This is the distribution. This symbol, tilde, means distribution. It must be normally distributed with a zero mean. So the mean must be zero. The mean of the error has got to be zero. And then the latter one is that it must be, the variances must be constant. Anytime you want to look at it, the measures of central tendency, we have the mean, the mode, and then the median. Okay. Then after that, you look for the variance. The variance is the deviation from the center. Okay. The average of the deviation from the center. And then when you take the square root of the variance, normally the variance is like sigma square. And when you take the square root of the variance, you normally will get the standard deviation. The standard deviation. Now, the rule is that for a regression to work, the errors must be normally distributed and the variances must be constant. That's what we mean by homoscedasticity. The variances must be constant. So there must be constant variance, not non-constant variance. So the variances must be constant and the errors must be normally distributed. If these are not met, the regression will not work properly. Okay. You don't get it, raise your hand. This is a technical thing. Now let's go to the next assumption. The next assumption are two. I'm going to talk about both of them at the same time. One is called autocorrelation. The other is known as multicollinearity. Autocorrelation and multicollinearity. What's the difference? Well, look at it carefully. Multicollinearity deals with the independent variables. Autocorrelation deals with the errors. But what is that? I want you to write this down. I'm telling you the meaning of multicollinearity. Multicollinearity exists. You are writing it down. That's right. Multicollinearity exists when two independent variables are so highly correlated that multicollinearity exists when two independent variables are so highly correlated that it becomes difficult. It becomes difficult to disentangle the partial effect of one from the other on the dependent variable. Multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to disentangle the partial effect of one from the other on the dependent variable. So what is multicollinearity? First thing you got to notice that it has to do with independent variables. It has to do only with the independent variables. It's not got anything to do with the dependent variable. Remember, the dependent variable is a y. Then dependent variables are x, but there are many, x1, you can have x2, you can have x3, and all of that. The dependent variable is one. And what multicollinearity is saying is this, that there should be no high relationship between any two independent variables. So let me give you an example. Assuming in your company, your manager tells you that, something is going to happen. You ask her, what is it? It says you see. This was when you were employed. And then 3 years into the company, you've seen a lot of people when they are sponsored. You've seen a lot of people being sponsored to go and do their MBAs in the university. The company actually sponsors them. And then when they return from their sponsorship, the day they come, their salaries are double. You have seen hundreds of people. But nothing like that is happening to you. You are 3 years in the company. Nothing has happened. And so one day you become embittered, goes to your boss, and then you ask, this is not fair. Your boss says, oh, sorry, actually, we have a policy in this company, and the policy is that Once you are 5 years in our company, we will sponsor you do your MBA. Upon your return, we'll double your salary. At this stage, you are calm because you know you have how many years left? At this stage, you know you have how many years left? I'm trying to see your answers before I move on. It means you have 2 years to go. Okay, so 2 years come, you truly get a scholarship. You go do your MBA. When you returned, your salary was truly doubled. My question to you is, what led to the increment in your salary? Was it the 2 years MBA you had, or it was the 3 years education, 3 years experience, 5 years experience that you had? What led to the increase in your salary? Was it a 5 years experience or the 2 years education? Give me your answers. 5 years or the 2 years? Some of you are doing lotto. So somebody says 5 years, 5 years, 5 years, 2 years, 2 years, 2 years, both. 2 years, 2 years, 5 years, 2 years, 5 years, 2 years, 5 years. Okay. I know somebody is saying some so that he too would know has said some. So ladies and gentlemen, the reason why you are struggling as to which one is because the two variables, education and experience, are multi-collinear. In other words, they are so close that you are even finding it difficult to disentangle the partial effect of each one on the dependent variable, in this case, W. So when two people are so close, you can say that they are multi-collinear. So if a husband and a wife are so close, or if even partners are so close, when you go home, tell your partner, do you know we are very multi-collinear? And if he or she is not drunk, he can do something to your face. Okay. But that's a way to remember the word, multicollinearity. Very close, so high correlation. That is what it means. Now, what is the difference between multicollinearity and autocorrelation? Well, there is not much difference except that, first of all, both of them are dealing with correlationship, interrelationships. But the main difference is that autocorrelation deals with errors, whilst multicollinearity deals with independent variables. Whilst multicollinearity deals with independent variables, autocorrelation deals with errors. So take note of that. Okay, so these are the assumptions of regression, and you got to know them. You got to know them by heart and understand and know them. Okay. I'll ask you 3 questions on this. Now, if there is no question, let's get to dummy variables. I'm doing all of this before we do the computer work, and Bernice is going to walk you on that. Bernice, are you around? Yes, she's around. Bernice, you're around, right? Bernice, are you around?
Yes, Doc, I'm here.
Okay, good.
Yes, Doc, I'm here.
So I'm going to let you walk them through the Excel and everything.
Yes, Doc.
Okay. So ladies and gentlemen, let me go to the next thing under the regression before we go through 2 exercises. Take note, 2 different exercises. Okay. We are going to use Excel, and then we are going to use R. Okay, R software is a beautiful software. But before that, let's talk about dummy variables. What is a dummy? Suppose somebody is calling you and you're not responding, and the person says, hey, dummy. What is a dummy? Dummy, statue. The word statue comes from the word, or the word static comes from the word statue. So when something is a statue, the thing is static. It's not changing. It's not dynamic. It is fixed. It's constant. It's a dummy. It's a categorical variable. So a dummy variable has certain things under it called levels. The levels are the ingredients of the dummy. The levels are the ingredients of the dummy. And one thing about the levels is that the number of levels are always one more than the number of dummies. Note it down. The number of levels are always one more than the number of dummies, which means the number of dummies are always one less than the number of levels. Let's take, for example, a dummy, which is called gender. Gender. Ladies and gentlemen, gender has how many levels? I mean, reasonably, depending on the continent where we are, okay? It deals with how many? Gender. 2 levels. What are the levels? What are the levels? One level is male, and the other level is female. So there are 2 levels. And therefore, whenever there are 2 levels, you have how many dummies? 1 dummy. So if I were to create a dummy, I can say that I'm just showing you how to create a dummy. Let M be equal to 1, or that is, let M be equal to 1, where M is male. Let male be equal to 1 or 0 otherwise, or 0 otherwise. Now, what does the otherwise mean? Otherwise mean the thing that is not male, that is a 0. So the otherwise here is referring to female. And then, so the female is a 0 and the male is a 1. Ladies and gentlemen, the level that is 0, that level is always called the reference category. The reference category. So in this case, the reference category is female because it's a 1 having the otherwise. Normally, when you write male, you don't write female as well. Okay, you only write 1 because the other one is inferred from the first one. So once I say a male, you see in my head, once I say a male, I'm talking about not female. 2 levels. So once I say all the males stand up, I am actually saying that all the males and not all the females. That's what I'm actually saying. So the female, whenever I mention the male, I'm mentioning the male in reference to the female. But I don't have to mention the female. Or suppose I'm talking about female, I don't have to mention the male. Okay, because when I mention the female, I'm talking about female in reference to male. Let's take another example, the one where the levels are more than 2. Okay, let's take another one like single, marital status. And we have the first one to be single. Okay, and I say let single be equal to 1 or 0 otherwise. That's what I said, or 0 otherwise. And then the next one, let's call it widow. I just don't want to go systematically. Let widow be equal to 1 or 0 otherwise. Then the third one, I mentioned divorce. Divorce. Let divorce be equal to 1 or 0 otherwise. There is one particular one I have missed there. Which one is that? There is one particular one I did not mention. And anytime I am talking about any one of these, that fourth one, which I did not give it a value of 1, that fourth one is a 0 otherwise. Which one is that? Is married. And I want you to know that the married here is not because you know they're married, but you should know that there is always one that is not mentioned. So how many levels are actually in this particular marital status here? How many levels are here? In this marital status, how many levels are here? It's not 2. It's not 2 levels, Nana. It is 4 levels. So how many dummies should we have here? That's good, 4 levels. How many dummies should we have? 3 dummies. 3 dummies. Somebody says 5. Hey, 3 dummies. And that is why you can see that I have written the 3 dummies. So anytime I write a 3 dummies like this, there's one particular dummy I don't write, and that is always the reference category. So what this means is that anytime I mention single, I am mentioning single in relation to married. Anytime I mention widow, I am mentioning widow in relation to married. Anytime I mention divorce, okay, divorced, I am mentioning divorced related or in reference to married. So married becomes the reference category. And that is the one that is a 0 otherwise. A 0 otherwise. A 0 otherwise. Okay. So you should understand what dummy variables are. Dummy variables are always categorical in nature. And they can take a value of 0 or 1, nothing else. 0 or 1, nothing else. 0 or 1, nothing else. Okay. That is if you want to code them, 0 or 1, 0 or 1, 0 or 1. In regression, sometimes you will have some dummy variables and they'll be included in the data set. Like we shall see examples today. Okay. But I want you to know that in regression, there is a possibility of always getting some dummy variables in there. You will learn more as we go through this practical example. And that is the Burukutu ventures. Burukutu ventures. We are going to take this. So what I will first urge you to do is that before Benny scans, what I'm going to let you do is that open your Excel on your computer. Okay, open your Excel on your computer and then open your R Studio as well. That Excel called Burukutu Ventures, open it right now and open your R Studio, not the R, but the R Studio.